Alright, in this video we're going to be continuing to look at this interest section 13.1, and we're going to be investigating compound interest. So this is one of the first homework questions regarding compound interest, and I just typed out exactly how I saw it. And you could be a little bit deceived as to how best to attack this problem, because I'm going to be presenting a formula, and I haven't even talked to you about the formula yet, but it's because it's not needed for this one. So if you look carefully, the principal amount invested is $925 at a rate of 4% compounded quarterly. So when something's compounded quarterly, it means every 3 months we tack on some interest, and tack on some interest 3 months later, and tack on. So it's not just one time a year. It is on a regular basis, in this case every 3 months or a quarter of the year. And we're going to do that over 7 years. And this was the final amount, $1,222.19. So they wanted to know that they're asking for the compound interest that was assessed. Well, that's easy. Just like in our old videos, or the last one that we did, the interest is just the difference between the principal and the final amount, or the principal and the accumulated amount, or the principal and the future value. And so in order to find the compound interest, let me get a pen here. That's no problem. We just have to take our final amount minus the principal, right? The initial amount. That would be that. And we have both here, $1,222.19 and $925. They just want to make sure that we're looking and understanding at these numbers that they're presenting to us. So $1,222.19, whoops, minus $925. The interest earned then was $297.19. So there's really no big work for us to do, just the subtraction of numbers that they gave us for that problem. That was one of the first ones I saw. It wasn't the first, but it was definitely towards the beginning. So this is the same chart, and so they do it more than once, but it's a little bit different. They didn't give us the final amount. They told us that it's being compounded annually for 27 years. Let me change that annually to something maybe a little bit more interesting. Let me put semi-annually. Semi-annually. So semi-annually just means twice a year, once every 6 months. So if we're going to find the compound interest, we need a formula to do that. And they developed the formula and present it at the top of page 736 in the textbook, right, that you have access to via the e-text. And I'm sure it's in the videos as well. This is the formula for the final amount generated when you have interest compounded multiple times a year. We still have P on the outside, and it's still 1 plus, but instead of R, it's R divided by N, and that's all being raised to the NT. So it looks a little bit more complicated, and that's because it is a little bit of complication to compound something. Now we should be able to just drop numbers into our calculator and hit one button and be done. So let's make sure we understand each of these symbols. A is the future value. Right? It may be called the future value like we saw before. It is the accumulated amount. And in this problem, it is the final value, or the final amount. Right? It's the amount that you get after the interest is applied. P we know is principal. We know R is the rate, and represented as an APR, right, an annual percentage rate. And then N is the number of times a year the interest is being applied. Right? So we'll talk about that in the context of our problem. So the only other variable is a variable that you know, t is time, and always in years. Awesome. All right, so that is our formula. Those are the descriptions of the variables that are there. Since you have a video of this, right, since this is in a video, I'm going to go ahead and erase this, knowing that you could back up and rewrite what those are. Just doing this for pacing in case somebody is studying along the way, right? Using this to take notes and go. So let's talk for a minute. What about in this problem? What we want is the final amount, which is A. We must then have a principal, which they tell us is 6,200. 1's a stagnant number, R is 0.045, right? Get that 0 in there. N would be the number of times it's compounded a year, 2 times a year if it's semi-annually. That N is involved again up here. And then the time is 27 over 12. So how would I plug this in? I would type in 6,200 times, right? So 6,200 times. And in use an open parentheses. Let me write out what I actually put in there. I said it, but I didn't write it. Times, open parentheses, 1 plus 0.045 divided by 2. Close the parentheses. And then hit the raise to a button. Mine looks like a little caret. Sometimes they look like y to the x. But you'll hit the raise to a button. And here's an important part. You need to use open parentheses because there's lots going on here. 2 times 27 divided by 12. And close them. And that should do it. And so we get the accumulated amount of $6,852.94. That's if the interest was compounded twice a year. If it was simple interest, let's see what simple interest would have done. The accumulated amount would have been, so if it was simple and not compounded, it would have been principal times 1 plus RT, which in our case would be 6,200 times 1 plus 0.045 times 27 over 12. So we got 6,200 times, open parentheses, 1 plus 0.045 times 27 divided by 12. And we get an accumulated amount of $6,827.75. And so they're different, right? Obviously you get a little bit more if it's compounded more often or not just simple interest. Now I saw something in the process. I didn't see that it said years up here. I did this in terms of months. I don't know why I thought that was months, but this would be the answer for 27 months. And so I apologize about that for not seeing it that way. So this would have, I just want you to see the comparison value in there. Let me come in here and erase this because what we have right now, what we have in this moment, okay, so let me talk about the years that was there before. There would have just been a straight 27 up there as opposed to 27 divided by 12. So let's do it for 27 months so we don't have to waste your time and redo that. We'll do another one here in a minute and we'll see what that one's like. But we're still not done. What we have is the final amount. I have the value that goes into that first box right up above. What I don't have is the compound interest. So the compound interest is going to be the accumulated amount minus the principal, like we did in the very first problem that we did. That's why it was there, to say, hey, that's the best way to capture the interest. To take the 6852.94, subtract away the 6200, and so let me do that. 6852.94 minus 6200, and in that 27-month period, there would have been in interest $652.94. So pretty cool in there. Now, this problem appears more than once in the homework. For each deposit, find the interest earned if the interest is compounded quarterly, monthly, daily, and then continuously. So it's multiple point problems, and so we'll talk about that right now. So let's make up an amount. Let's suppose that we're going to invest $8,000, and they want to know the interest earned if it's compounded quarterly, monthly, daily, and continuously. So $8,000, let's suppose our interest rate is 4%, and the time that we're leaving it in for is 5 years. Okay, let's do part A. If it's going to be compounded quarterly, I have to use the big formula. A is equal to P times 1 plus R over N to the NT. So if it's compounded quarterly, I'm going to take my 8,000, 1 plus, my interest rate is 4%, so 0.04, divided by quarterly would be 4 times a year. So that's 4, and we're going to do that over a 5-year period. And what this will give me is not the answer to the question, but will help me get the answer to the question. So we get 8,000 times 1 plus 0.04 divided by 4, close parentheses, to the open parentheses, 4 times 5. Or if you know that that's 20, you can just put to the 20th power. And here's what I get. An accumulated amount in the end of the 5-year period of $9,761.52. So the interest earned, which is what they're asking, is the 9761.52 minus 8,000, which nicely is 1761.52. That's the answer to part A. Part B, what if I compounded it monthly? Well, what would change in here? Well, my 8,000 wouldn't change, so I'll leave that in black. My 1 and the 4% wouldn't change, and my time being 5 years wouldn't change. But what would change? The fact that I'm having it done 12 times a year. And so we would then run this calculation. 8,000 times 1 plus 0.04 divided by 12, close parentheses, to the 12, well, in open parentheses I almost didn't, I would have had the wrong number, 12 times 5, or 60. And here's what my new number is, 9767.97. So I earn a little bit more. How much more interest? 1,767.97 is the interest earned on that one. So roughly like $6.40 more. That's if it's compounded on a monthly basis. If it's a daily basis, right, we're going to have the accumulated amount is equal to 8,000 times 1 plus 0.04, and they'll always use 365 as the number of days, and so that's 365 times the 5, right, because it's going to be compounded 365 times. Let's see what that does. So we take 8,000 times 1 plus 0.04 divided by 365, close those parentheses, to the open parentheses, 365 times 5, right, the number of accumulations, right, the number of times it's going to be assessed. And let's see what we get if we hit equals here. So if it was done every single day, we get $9,771.52. and 11 cents. 9771.11. And so the interest earned would be that minus 8,000, so $1,771.11. Now, you could think that this would grow without bound, but that's what Part D is dealing with, continuously compounded interest. There we're going to use a special number, and it's in our book. Let me see if I can find out where they do continuously compounded interest. On page 740, this is the formula for continuously compounded interest. PE to the RT. So this E, right, button is on your calculator because it is a number. E is like pi. It's 2.7182818828, and it just keeps going on forever. Right? It's this, they call it the natural number because it describes how things behave in nature, including compound interest. So this button's on your calculator. The accumulated amount then would be the 8,000, right? That's my principal. E's just a number. It's there on your calculator. The rate's 0.04, and the time involved is 5. And so we're just going to type in 8,000 times and find the E to the button. So I'm typing in 8,000 times. I found my E to the button, and it looks like that. And then I'm going to just type in 0.04 times 5. And I'll close it off. I don't think you need to, but I think calculator automatically do that. But look what the accumulated amount is. You can think that it's going to be really drastically different because they all kept growing. It's roughly the same as it was for the daily one. So that's why most will just do daily. It's easier with daily. Credit cards do daily because if you paid on the 5th day of the month or 5 days late, they know how much to assess you. So this would be 1771.22. So you made an extra 11 cents by having it compounded on a continual basis. So this is what you do for compound interest, right? You just follow that formula. We'll look at one last video from this section in which we will look at some what I call beyond the basics problems, some formula manipulation type of problems, but they're completely doable. All right, thanks guys.